All right, let's get started. Hello, everyone. I'm Spin from TetraScience. Let's talk about data as plumbing for the digital lab. So this Tuesday, John Conway from 2015 Visioneers talked about his analogy between R&D organization and a building. He talked about power, communication, virtual capabilities, infrastructure. And he also talked about plumbing as the data and processes and instruments. So today in this presentation, we will focus and zoom in on the data plumbing part of the R&D organization. In this presentation, we'll define what is data plumbing for the digital lab. We'll then talk about the requirements of a such lab data plumbing system and what you should consider while building one yourself, and the impact of not taking action or the lack of that data plumbing system, and also our recommendations for how to get started. In terms of defining data plumbing system, we want to bring you back to your home. When you think about plumbing, you may think about having running water, having running dishwasher, laundry machine, right? That's especially when we're all sheltering at home. Those are essential. Plumbing can also be extremely complicated when you think about it in the context of a New York City skyscraper. Think about it as the sports stadium. Think about it in the context of a New England aquarium. Similarly, for the biotechs and the pharmaceutical companies today, the lab, the data flow in the lab is equally, if not more, complex. In a lab, you have heterogeneous instruments, different brand models. They produce disparate file formats, distributed partners such as CROs and CDMOs that are doing research in an outsourced manner, different applications such as registration, inventory, ELN, LIMS, and your own applications. There are many workflows that scientists are running, different kind of experiments, assays, and also increasingly more popular new visualizations and analysis tools that the data scientists are introducing to this ecosystem. So in our definition, the lab data plumbing is the collection, cleansing, harmonization, and movement of your lab data. Just like the plumbing at your house, it can be messy and dirty. It involves the flowing of information or water through a complex system. It is simple to start, but quickly can become very complicated, requiring special skill sets, tools, and careful design. So let's think about some of the day-to-day kind of examples of data plumbing in your lab or in today's lab. CRO will send a huge volume of Excel spreadsheets, PDFs over email or via file share. The scientists will have to manually download them, perform quality check, making sure the barcode is available in the registration. The assay should be performed on 3 mice instead of 2 mice. Scientists may copy-paste the data from their lab instruments into a lab notebook. Then they manually transcribe the data into the ELN. This process often requires second scientist review and third scientist review in a compliant environment. The data scientists have to manually compile the results, aggregate data from multiple batches, samples, aliquots at different time points into an Excel spreadsheet to align the curves, to illustrate trend and anomalies. These kind of data plumbing is happening every day. They're just not automated, but data plumbing is already present in the lab. So now once we have defined data plumbing in the lab, let's talk about what should this, if we were to have a plumbing system, a data plumbing system similar to the ones in the building, what should the requirements be? And we're going to use the analogy to give us some inspiration on what are the sort of product requirements or expectations we should have for this kind of data plumbing system. So let's start by thinking about the plumbing system at our house. We do not want dirty water to come into our building, right? Incoming water should often undergo additional filtration and sanitization. It's the same analogy requirement here. You don't want dirty or untagged data going to your data lake, your ELN, your LIMS, your visualization, or your reports. Even though it is crucial to collect as much data as possible from different sources, it is equally crucial to attach the right metadata and perform validation and data harmonization. Second, there will always be leaks, broken pipes, clogs, causing drips and floods, right? All the annoying stuff. There can also be processing errors in the data plumbing. As a result, there needs to be an alerting and notification system to show the missing data, the processing failures, any kind of throughput bottleneck or fluctuation. You may imagine suddenly the file size is much larger and you're seeing a lot of out-of-memory issues. So all those needs to be tracked and proactively alerted. It'll be impossible, it'll be a nightmare to map out how the water is flowing, how are the pipes connected without a building floor plan. It's the same. It's important for us to view and manage the data flow from a central dashboard. Think about a Google map, right? Think about having a system like that, having a visualization tool like that to show how your lab data is flowing across the systems in the lab. You want to be in the plumbing side, you want to easily swap out or replace a sink or shower head without changing the rest of the system. You want the same level or maybe more degree of a kind of configurability, enabling labs to change an instrument or application without impacting the rest of the system. And you want to easily plug in multiple ways to consume the data. You want to put in Spotfire, Tableau, then you want to put Jupyter Notebook, you want to put R, you want to put some kind of other visualization tools or your own applications. You want to do that in a plug and play fashion. And lastly, if you think about water going to the building, it comes with some pressure. That's how water gets to travel upstairs. It's the same with data plumbing. If you connect a new data source, if you ingest data from the last 2 years of experiments, if you have a new CRO, if you started to run a new type of experiments, if you started to have your robotic system kind of running the plates, it will introduce a similar pressure called data ingestion pressure, right? Suddenly builds up, the amount of data builds up. So you want to have proper throttling, load balancing, and auto scaling to handle the new data sources. So these are just some of the requirements that we feel we can gather by thinking very intuitively about our daily usage of the plumbing system in a building. But at the same time, the data plumbing system for the lab will have its own unique challenges. For example, collecting data from the instruments can be very, very challenging. It's not like the waters will just flow into the building. No, it's a fight to get the data out of the instruments. Comprehensive and immutable logs of data processing is crucial because a lot of the transformed data will be used in submission or quality processes. You want to be able to rerun or replay the data flow, right? You want to be able to do that and extract new metadata out of the raw data. You want to merge the data streams. You want to steer the data to different places. So that represents some unique challenge. Oops. You want to rapidly customize and upgrade your pipelines, especially when you are encountering new type of studies, new type of insights you want to gather. And finally, you want to do all of that while keeping track of the changes and upgrades to those data processing tools, such that there is a thorough audit trail for the CFR Part 11 purposes. So now we talk about the requirements of a data plumbing system. Let's think about the impact of not having one. Again, we're going to use those examples. For example, CRO data gets in, scientists will have to manually triage them, manually copy the data from the instruments to the notebook, to the ELN, requiring your peers in the lab to review them. Data scientists have to wrangle the data together, aggregate them, align the curves, just to be able to plot something, be able to detect a pattern. And if you think about it, it's very typical for a lab scientist to spend 10 to 20 hours per week just on those kind of plumbing type of work. And if you scale this to a larger organization, for one that has hundreds to thousands of scientists, we're talking about up to 1 million hours spent per year cumulatively just on this data wrangling. So it's a real problem. And you're talking about 125 million just in terms of money wasted on this. Again, this is a meaningful, sizable, fundamental problem in the lab. If we think about the opportunity cost, what could the scientists do with those 1 million hours of productive time? Or quite honestly, uninterrupted time. If you think about what could a data scientist do with clean and accessible and prepared data at your fingertips. And let's also think about what's the implication of errors, transcription errors, or the lack of information recording, propagating downstream. Think about the rippling effect there. So having talked about all of that, my hope is to provide some very quick and simple recommendations to the audience here. So our recommendation is to plan the data plumbing system for your lab as a first level architecture considerations, not an afterthought. Not that after you have the instrument, you have bought the instrument, you have bought the ELN, and then think about how to connect them together. Think about the data plumbing system as the for the IT folks, a message bus. Then you plug in the data publishers or producers or the data consumers. Think about it as a traffic system, right? Think about when you buy a house, before you move in, before you decide which dishwasher, which laundry or dishwasher you buy or you're going to use, the plumbing is already there. Think about the movement of your data as a first class consideration. And the second recommendation is start now, right? Don't let the scientists and data scientists just spend their time on the data wrangling. That's a lot of data they're going to wrangle with. They will get frustrated, they will miss data, they will make mistakes, and they will not produce the kind of insights and analysis that you want them to do. So that's our presentation, and that's our thought on data plumbing. And I'm Spin from TetraScience. Thank you very much.